This video today is going to be looking at energy, work and power. Now, energy is the ability of any object to basically make something happen. And if something useful happens, we say that work has been done. That's the expression that's used. And in mechanics, we're going to be focusing on two main types of energy. That's kinetic energy, the energy of anything that's moving, and potential energy, which is basically stored energy, which has the ability to make something happen. So a store of energy. So there are two types that we're looking at. And how we transfer energy is through forces that we've already looked at. So a force will transfer energy and will do work. Now, if we remember back to GCSE, you might already be aware of one of the equations. We're going to use Percy as an example to look at what happens. Percy's going to move from the left-hand side of the screen to the right-hand side. Okay, you'll see that my finger is putting a force in there and is moving Percy from one side to the other. So work has been done by the force of my finger pushing Percy along, quite simply. Okay, now if we added a troublesome truck to the equation, okay, then that's going to mean that a bigger force is needed, so more energy is transferred. Also, the distance we move Percy will also have a factor on what's going to happen with regards to the energy. So the equation is simply, for this one, work done is force multiplied by the displacement. Okay, at GCSE it was distance moved. At A level we'll be a bit more precise and use displacement in the equations here. Now there's a couple of things we need to be very careful of with this equation. First of all, with regards to the force, we're making a couple of assumptions about the size of the force. We're either in the equation saying that the force is constant or an average force. So the average force applied through the journey. And the displacement, quite critically, is in the same direction as the force. Work, type of energy, so it's measured in joules. So the next section is to look at what happens if the force and the displacement are not in the same direction. An example of this might be we take our troublesome truck and we put him on the rails again, but Percy, say, is broken down, so he needs a bit of help. So in comes Harold the helicopter. Now Harold the helicopter has to fly to pull the truck along, so it would be connected to the troublesome truck maybe by a cable that way. Okay, the displacement of the troublesome truck is still in that direction, but the force now is the tension in the cable and follows that direction, and will make an angle with the ground theta. Okay, now it's only the component of the force in the same direction as the motion, in the same direction of the displacement, that's going to count here. So what we've got to do is resolve that force into its horizontal component in the example we've got, and we'll see that work done is then F cos theta. Okay, this is a closing angle, so it's cos multiplied by the displacement. More commonly, that would just be written as W is Fs cos theta, where theta is the angle between the force and the displacement. The final factor to consider in this introductory video is the idea of power. Now, by definition, power is the rate of energy transfer or the rate of doing work. So power would be work done divided by time. And if we think about our objects we've had a look at so far, we've got Percy. Okay, he's a small engine, so he would have probably quite a low power output compared perhaps to Gordon, the big blue engine, who would have a much larger power output. He would be able to transfer force and therefore do work a lot more in a lot shorter time than Percy would. Final thing to look at is, well, in that equation we know that work done is Fs, and so power would be Fs divided by T, and here we've got displacement divided by time, which simply, if we've got a constant velocity, would simplify this equation down to power is force multiplied by velocity. And again, if we think about Percy and Gordon, well, Percy is going to be a much slower engine than Gordon, who by and large is based on the Flying Scotsman.